welcome to Online Lecture 3 on functional groups. Today we're going to be talking about a bunch of the common functional groups that we see in organic chemistry. I just want to stress that these aren't necessarily the IUPAC names. These are just the types of names that have been accumulated over the years that you'll see written in common language, just in your textbook, in example problems, so it's good to be familiar with them. The first group we're going to talk about is an alkene. An alkene, by definition, is any hydrocarbon with a carbon-carbon double bond. It's really that simple. So an example might just be something like this, or something like this, or this. Anything that looks like it has a double bond in it. There can be any chains coming off as long as there's a double bond. An alkyne, by definition, has a carbon-carbon triple bond. So that could look like this, or this. It really doesn't matter as long as there's a triple bond. And we typically draw triple bonds linearly because carbons with a triple bond are sp hybridized, meaning there's two groups, they're separated by 180 degrees, they're linear. It's always going to have that triple bond in a linear sense like that. Next, let's talk about arenes. Arenes are actually a subset of something called aromatic compounds. And an aromatic compound is a special type of organic chemistry molecule that essentially is a flat ring that has resonance of pi electrons. So the flatness and the fact that the pi electrons are resonating makes it very stable. So this is a very common thing to see. There are many types of aromatic compounds and groups, but the type that's most common that we're going to be focusing on is benzene. And benzene is this red part here that is essentially a 6-carbon ring with alternating double single bonds. That is an aromatic compound that is called benzene. So anything that has that group is going to be looking something like this, or like this. That group, as a functional group, is actually called an arene. So benzene, arene, those names are basically interchangeable. Next, let's talk about alkyl halides. So as we know, halogens are group 7 on the periodic table, and an alkyl halide is essentially any hydrocarbon that has a halogen group. So that could look like this with a chlorine, or this with a fluorine, bromine, or an iodine. And so the general way that we represent a halogen is with an X symbol. An X simply means that it could be any of the group 7 elements. So fluorine, chlorine, bromine, iodine, any of those connected to a carbon makes an alkyl halide. Next, alcohols are actually one of the most common things, one of the oldest type of organic chemistry molecules known. And by definition, it's just any hydrocarbon that has an OH group on it. So there's ethanol, which is the type of alcohol that we drink. There's isopropyl alcohol, like that one. That's common for rubbing alcohol, for removing things as a solvent. And there's many other types of alcohols, anything that has an OH on it. So the general form, carbon attached to OH, is an alcohol. One specific type of alcohol is called a phenol. A phenol is any compound with an OH connected to a benzene. So by definition, it has to have a benzene like this and an OH coming off of it. And then whatever else is attached to it, doesn't matter, it's still considered a phenol. So it can have a bunch of alkyl chains. It's still a phenol like that. By definition, it just has to have the benzene and the OH. A thiol, by definition, is any compound that has an SH group. So because sulfur is right under oxygen on the periodic table, It has the same number of valence electrons, and it actually acts like oxygen chemically in many instances. And so we put thiol at the beginning of the name to represent sulfur instead of oxygen. So something like that, or that, or that. Anything with that SH group is going to be a thiol. Next, let's talk about ethers. Ethers, by definition, have a COC pattern. So now oxygen is not bonded to a hydrogen, it's bonded to two carbons simultaneously. Anything with that pattern is called an ether. So there's one, there's two, it could be in a ring as well. Doesn't matter, as long as it's COC, that's considered an ether. Next, we're going to talk about epoxides. An epoxide always has an oxygen bonded to two adjacent carbons. So what does that look like? If we have two adjacent carbons in a chain, and we have an oxygen bonded to each one, we actually create a CCO ring. So all that means is that if I have a chain of carbons, I need to have that oxygen connected to two adjacent ones. That is an epoxide. So by definition, we have to have CC with O bonded to adjacent ones and create that little triangle ring. Any carbons coming off are fine. That's an epoxide. So let's talk about ketones. A ketone is a group that has a CO double bond. So something like this with CO and any alkyl chains coming off, or this, it can be on a ring as well. There's another name for the CO group, and that's called a carbonyl. So ketone is usually referring to the class of molecule or compound. Carbonyl is referring to the specific OC group. And that's the general form that we typically see a ketone look like. Let's look at aldehydes. An aldehyde is similar to a ketone. It has a hydrogen next to a CO group. So this is essentially a more specific type, and it's always going to have that hydrogen connected to the CO. So let's look at an example of that. Typically, we do draw the hydrogen explicitly, even though the line notation doesn't require it. If we were to draw it without that, it would essentially look like this. That's the same thing, just without the hydrogen drawn, but that is an aldehyde. Next, we're just going to make one change and make something called carboxylic acid. A carboxylic acid is a carbonyl with an alcohol next to it. So if I draw a carbonyl, and then I draw an alcohol off of that, I can put anything over on the other side of this carbon, and that is a carboxylic acid. That's a very common group. It's a very strong acid. It shows up a lot when we're dealing with acids in chemistry. Esters are similar to carboxylic acids. Instead of an OH group, we have an alkoxy group. So we have a carbonyl again, and then an alkoxy means that there's an O with some alkane chain attached on the other side. So now we're just adding more complexity. But as long as there's this C double bond O with another O, that is the general form of what's called an ester. That's a very common class of molecule as well. Now let's start talking about compounds with nitrogens. An amine is essentially any compound with a nitrogen next to an alkane. So for example, this compound, nitrogen next to an alkane, that is an amine. The NH2 is just one type of amine. You can also have the nitrogen having one hydrogen and then another group on the other side. Or you could even have the nitrogen with two groups coming off of it like this. The typical way that these types of amines are referred to is a primary amine, meaning there's one alkyl attached to it, a secondary, meaning two, or a tertiary, meaning three. You can actually even have four things attached to a nitrogen. In that case, the nitrogen is now positively charged because it only sees 4 electrons. The other groups have a lone pair. This one doesn't. So this one is a quaternary amine. So the general form is anything with a carbon attached to a nitrogen, like that. An amide is very similar to an amine, but this one is a more specific subgroup. It's a nitrogen next to a carbonyl. So by definition, carbonyl, nitrogen next to it. So it's similar to an ester, except this time there's a nitrogen instead of an oxygen here. And again, there can be alkyl here, there can be a hydrogen here, and then there can be anything you want over here. That is an amide. Anything with that type of group, with the O double bonded to a C next to an N, that's an amide. Nitrile is essentially anything that has C triple bonded to N. This is a very common group as well. So you could have this group. You can have this group. Sometimes the triple bond is not drawn explicitly because it's known to be there. That group is also referred to as a cyanate. So we've gone over a bunch of the most common groups that you find in organic chemistry. There's also acetals and hemiacetals. Those I didn't go over explicitly, but you may see those as well.